Hi, for this recording, I'm going to show you how to find the trigonometric Fourier series of a function. The function is given equal to 2t for t between minus pi to pi with a period of 2 pi. We are going to show that the Fourier series is equal to 4 times summation of n from 1 to infinity minus 1 power n plus 1 over n sine n t. I have sketched the function now. You'll find that the function is equal to 2t from minus pi to pi, which I draw here. For example, when t equals 0, y equals 0, when t equals to pi, ft equals to 2 pi, and so on. This graph is extended from pi to 3 pi, also same shape, and minus pi, 3 pi to minus pi, also same shape here. To find the Fourier series. What is the Fourier series of a function? The Fourier series of a function is given by a0 plus summation of my an cosine n omega 0 t plus bn sine n omega 0 t, whereas a0, an, bn, and so on are given by this integration formula, and omega 0 is 2 pi over t, where this t is the period. Alright. Now let's take some advantage of the function. We know the function f of t is t, so f of minus t is equal to minus t, which is negative of ft. So the function is odd function. If a function is an odd function, then a0, an are all 0. That means that if you go back to the Fourier series, you know that this a0 is going to be 0, an is going to be 0. So you only need to find bn. That means we only need to find bn. So let's look at the formula for bn in order to find the Fourier series. Here, the period is given as 2 pi. So omega 0 is 2 pi over t. The period is 2 pi now is equal to 1. Therefore, this number omega 0 is 1. And period is equal to 2 pi. Therefore, bn eventually is equal to 1 over pi. Right? From k to k plus 2 pi ft sine nt. Now, you take advantage of the function ft sine nt is even. Why is it so? This is because ft is odd, sine nt is also odd. When you multiply an odd function with odd function and multiply, this is an even function. So ft sine nt is even function. Now, if you have even function, let's take advantage of k now. We're going to take k equal to minus pi. So you take k equal to minus pi, then integrate a function from minus pi to pi. So since the function is even, now you look at the graph for even function, it's symmetrical about the y-axis. So the area under the curve from minus pi to pi is actually double the area from 0 to pi. Therefore, you can actually integrate from, instead of from minus pi to pi, integrate from 0 to pi, and then you multiply by 2. Alright? And so ft is equal to 2t now. I'm going to put in ft equal to 2t from 0 to pi, since we are given that function ft equal to 2t. Right? So from 0 to pi, so we put it in. Ft is 2t. So that you have this integral. Pull out the 2. So 2 times 2 we get 4. So we get 4 over pi for integrate from 0 to pi t sine nt. So we're going to do this integration. And this integration require integration by part. So I'm going to show you how to do integration by part in a table form. So t sine nt, what you do is take one column of t, write down t in one column, and sine nt in another column. What I'm going to do now, differentiate the column under t with respect to t. So for example, differentiate t with respect to t, I get 1. Differentiate 1 is a constant now, with respect to t, you get 0. Next, for the sine nt, I integrate sine nt. Now integrate sine of a function. Sine at is negative cosine at over a if a is a constant. So integrate sine at will give you minus cosine nt over n. So afterward, they integrate again. So integrate cosine, I got sine now. So integrate cosine at, got sine at over a. So integrate cosine, I get sine now. n t and divide by n again. So this time divide by n 2 times get n squared. And I'm going to draw arrow now. So I'm going to draw arrow downwards one level. This is a method of integration by part, very popular. And you draw, label the arrow with a plus sign, start with plus sign, then minus sign, and plus sign, and so on in this case. Now the formula, the integration formula will give you this. What you do is multiply the terms, all these multiply together. You're going to get, together with the sign, you get minus t cosine nt over n. And then multiply this together with minus sign. Okay, 1 times minus sign nt over n squared, you get plus sine nt over n squared. And if you continue diagonal one, you're going to get 0, so you can ignore all this since 0 times anything is 0. And this is how you get the integration from t sine nt. Now I want to put the limit. The limit of integration is from 0 to pi. So I'm going to put the limit from 0 to pi now. So 0 to pi. So you put in the limit when t equal to pi, you get minus pi cosine n pi over n plus sine n pi over n squared. This when t equal to pi. And then you put t equal to 0. Now first term we put t equal to 0 got 0. Second term get sine 0. Now sine 0 is also 0 actually. So we know that sine 0 is 0. How about sine n pi? Now sine n pi, we can observe that sine n pi is always 0 because sine pi is 0, sine 2 pi is 0, sine 3 pi is 0. As long as n is an integer, you get 0 there. How about cosine n pi? Now cosine pi is very special. Cosine pi is minus 1. Cosine 2 pi is 1. Cosine 3 pi is minus 1. Cosine 4 pi is 1. So cosine n pi in fact is equal to minus 1 power n. You can check that. Therefore, the integration now, putting it, this integration from 0 to pi, t sine nt is equal to minus pi times minus 1 power n over n. Because the rest of the term is 0, so this is minus 1 times minus 1 power n is minus 1 power n plus 1 pi over n. And then we are able to find out what is bn now. Bn, remember, is 4 over pi integrate from 0 to t sine nt. And I have found out that the integration with the limit is pi times minus 1 power n plus 1 over n. After cancellation, pi and pi cancel. So you get 4 over n minus 1 power n plus 1. This is my Bn. Therefore, the Fourier series is something like summation of Bn sine nt since omega 0 is equal to 1. And there's no an here, there's no a0 here because they're all 0. Now put the value of Bn we just obtained. The 4 over n minus 1 power n plus 1 sine and t. So this is the Fourier series for ft now.